So let's start off with first the easy questions of integration. So the questions which use the basic formulas which you have seen in the last lecture. So let's start off with the first one. So let's say we have integration dx upon 2 minus x. Now, whenever we get a question of integration, we just try to match it with the available formula. So 1 upon x, I have the formula for 1 upon x. 1 upon x dx is equal to ln x plus c. So I will use this formula. The only difference is here there is minus sign. So there is actually a binomial 2 minus x. So how integration works is you write this as ln of 2 minus x and you divide by the derivative of this. So 2 minus x, the derivative is minus 1 plus c. So the final answer which you get is minus ln 2 minus x plus c. So this was the first question. Let's try the next one. So the second question says you have to find the integration of sine x plus cos x plus 2 dx. So when I look at this question, I see that these are just standard formulas that directly you can use the integration formula. So integration is on addition, you can separate the integration. So I can write this as integration of sine x dx plus integration of cos x dx plus integration of 2 dx. So over addition or subtraction, you can just distribute the integration. So integration of sine x is minus cos x. So direct formulas. Integration of cos x is sine x and this is 2x and plus c. So this is the answer. So for 2, the thing is that for 2, it's like 2x raised to 0. So the formula is x raised to n dx, that is x raised to n plus 1 upon n plus 1. So this is x raised to 0, so it's x raised to 0 plus 1 upon 0 plus 1. So that's why it comes as 2x. Let's see the next one. So the third question. So third one is, let's say we have integration of root x plus 1 by root x the whole square. Now the problem with integration is that now if this would have been a question of derivative, we could have just taken the derivative of whole square and applied chain rule. But integration doesn't work that way because inside, if it's anything except x, then we can't directly use that integration formula. So the integration formula we have for x raised to n dx, if I had square, I could have just used this formula. However, now I cannot use this formula because inside you don't have x, you have root x. If you have a single x, then I could have used this formula. So what I can do is then I can expand this. So this is a plus b the whole square. So root x ka square, that is x plus 1 upon x, because a square plus b square plus 2ab, which is actually 2 dx. Now this is a straightforward question. Integration of x is x raised to 1 plus 1 upon 1 plus 1 plus 1 upon x is ln x plus 2 is 2x plus c. So this is x square by 2 plus ln x plus 2x plus c. Let's try the next one, the fourth question. So let's say we have something like integration of e raised to x log a plus e raised to a log x plus e a log a. So this is the question. Now for such a question, we can clearly see this x can come here by power law. So I can write this as integration of e log of a raised to x plus here I can again use the power law and I can write this as integration of e raised to log x raised to a, and this I can write e log a raised to a dx. So I've just used the laws of log and use the power law. Now there is a very important formula for log and e, and that is if you have something like this wherein this is the base and this is log and this is x. If this base and this base is same, then this is equal to x. So using this concept, this is e and this is also e, as the base is not given. This is also e, so both are e. So this will be a raised to x. So integration of a raised to x plus this would be x raised to a plus this would be a raised to a dx. Now we'll apply integration. So this is a raised to x. So a raised to x, the formula is a raised to x upon log a plus x raised to a. So this is variable raised to constant. So this is x raised to a plus 1 upon a plus 1. And this is constant raised to constant. So this is a raised to a into x plus c. So this is how we solve this question. Let's now try some more sums which are using trigonometric functions. So let's say we have something like integration of tan square x. See now again, if you recollect, if this would have been a question of derivative, so tan square x, we could have easily done this as, we could have written this as tan x the whole square. Then we could have taken the derivative, we can do chain rule, and you would have written 2 tan x, and then derivative of tan x, we can write derivative of tan x, that is sec square x, and we could have completed the question. But again, this is not as simple as derivative. So what happens is in integration, again if you see, since this is tan x the whole square, we can't use the formula of x raised to n. Why? Because inside there is not x, there is tan. So again what you'll do, you'll try to manipulate. Now tan square x I can write as, using the identity, I can write this as sec square x minus 1 dx. Now sec square, we know the integration of sec square is tan x, and integration 1 is x plus c. So this is the answer, right? Let's try one more. So integration is more about manipulation and then trying to get this formula. So let's say the question is 1 upon sine square x cos square x dx. Now in integration we don't have u upon v. So this is 1 upon sine square cos square. So again we need to manipulate. So the best manipulation we can do in this case is, instead of 1 I can write sine square x plus cos square x upon sine square x cos square x dx. Now you can just separate, because see this is like a v, so we can separate. So I can write sine square upon this, so sine square gets cancelled, 1 upon cos square is sec square, plus cos square upon this, so cos square gets cancelled, 1 upon sine square is cos x square x. So that's it. Now we can solve. So integration of sec square is tan x, and integration of cos x square is minus cot x plus c. Let's try one more. Let's try a little complicated question. Let's say, uh, let's say we have a question like this: integration of sine raised to 8x minus cos raised to 8x 1 minus 2 sine square x cos square x. So again, we don't have u by v, and this is power of 8. So what I'll do is, first I'll use a square minus b square. So I can write this as sine 4 power x minus cos 4 power x into sine 4 power x plus cos 4 power x upon Now see, instead of this one, I can write sine square plus cos square minus 2 sine square cos square. So I can just keep this as it is, 2 sine square x cos square x, and this is dx. Now, many students make the mistake of writing sine raised to 4 plus cos raised to 4 as 1. So this is not 1. Sine square plus cos square is 1. And this can be further manipulated. So sine raised to 4. So this I can write as sine square x minus cos square x into sine square x plus cos square x into sine raised to 4x plus cos raised to 4x dx. And in the denominator, so in the denominator, see, we have a square plus b square minus 2ab, right? So what we can do is, and this what I'll do is, see, this is 1. So this is 1. So I can write this as 1 square. So in fact, I can write this whole thing as sine square plus cos square, the whole square. So now, if you open this, so if you open this, what you'll get sine raised to 4 plus cos raised to 4 plus 2 cos square sine square, and here you have minus sine square cos square. So this gets nullified, right? So let me just show you this. So what I'll do is I'll just open this. So I'll have sine square the whole square plus cos square x the whole square plus 2 sine square x cos square x, and here you have minus 2 sine square x cos square x. So these terms get cancelled. Now this is 1, and now if you watch carefully, this is sine raised to 4 plus cos raised to 4, and this is also sine raised to 4 plus cos raised to 4. So this entire thing gets cancelled now, and this is 1. So this also actually goes. The only thing left now is this sine square minus cos square. So I can write this as minus cos square x minus sine square x dx. And the reason I have written it in this way is because here I have a formula. This is minus cos 2x dx. And now we can easily get the answer. Integration of cos x is sine x. So you have minus sine 2x. But since it is 2x, we take the derivative of 2x, which is 2, and divide by 2 plus c. So this was a bit complicated question, but we could easily, using some manipulation, we could solve it. So I hope you enjoyed this video, and till next time, take care. Bye bye.